Welcome back. In this video, we will learn about the mole and molar masses. What this entails is using Avogadro's number and the relationship between mass and moles to calculate the masses of individual atoms and molecules, mole quantities if you're given the mass amount, and vice versa, and then also determining the number of particles if you're given the mass of a substance or the mole of that substance. So let's talk about the mole. A mole is a fixed number in the same way that a dozen is a fixed number. So a mole is also referred to as Avogadro's number, and it is the number 6.02214 times 10 to the 23rd power. That's a massively huge number. If we talk about a dozen, that's when you have 12 of something. So if you have a mole of something, you have 6.02214 times 10 to the 23 of that object. And any collection that has Avogadro's number worth of those objects is referred to as a mole of those objects. So just to give you an idea of the scale of this, this is the value for 1 mole, 6.02214 times 10 to the 23. This is a trillion, and this is a trillion. So 1 mole's worth of something is approximately 1 trillion trillions. And you can have a mole's worth of anything, literally anything. You could have a mole of bananas. You could have a mole of hats. You could even have a mole of moles. In fact, there is a link here to a comic strip where someone hypothesized what would that look like if you actually had a mole of the creature, the moles. So I encourage you to read over that if you'd like a humorous analysis of this. So the takeaway here is that a mole is just a fixed number, and you can have fractions of moles, you can have multiple moles. For example, you could have half of a mole of bananas, and that is 6.022 times 10 to the 23 divided by 2, which is still a massively large number. Or you could have 10.5 moles of bananas. So you don't need to just have a single mole, because a mole is a large collection, just like you can have 2 dozen or 2.5 dozen of any particular item. So let's use this in some examples. If you wanted to know how many donuts you had, if you had 5 dozen donuts, what you would do is you would start with the amount of the substance you actually have. What do we have? We have 5 dozen donuts. And then we use the ratio that involves the dozen and the number. So a dozen is 12. So we would multiply by 12 donuts per 1 dozen. When you do this, because you have the same units in the numerator, dozen, and in the denominator in this ratio, those units will cancel out, and we see that we have 60 donuts. We can perform this same type of manipulation involving moles. So if you have 5 moles of atoms, the thing that we have is moles of atoms. So you start with that. You've got 5 moles of atoms. Then we use a ratio. We multiply by a ratio such that we can eliminate the moles and just get a number. And so that's when we use Avogadro's number. Avogadro's number is used to convert between moles of any substance into the actual numerical value of that thing. So if you have 5 moles of atoms, you multiply by Avogadro's number, your moles will cancel. We're left with atoms. And so we have 3.011 times 10 to the 24 atoms. We can use Avogadro's number and molar masses in order to connect mass to moles. We use the molar mass for that. And to go from moles to number of particles, we use Avogadro's number. And so this diagram shows you what type of operation you would use in order to convert from one thing to another thing. And in future videos, we will do multiple practice problems involving this. But that's it for this video. Thanks for watching. Have a great day.